Okay, we can get started. 9.2. We're going to solve by elimination. So this was the other method that you guys learned in Algebra 1. Yesterday we did substitution. Today we're going to do it another way. In order to solve using elimination, we need the same number in front of our x and y, but they need to have opposite signs. So we can say that they need opposite coefficients. Opposite coefficients. What does that mean? That just means if I have, let's say, I don't know, a 2x and a negative 2x, those are opposite coefficients, right? They have the same number in front, just opposite sign. If I had like a 4y and a negative 4y, those are opposite coefficients. They have the same number, just opposite sign. We're going to try to get opposite coefficients if they are not there already. To do that, you're going to multiply one or both of your equations by a number so that they get the same number, just opposite signs. And then once you do that, you're going to combine your equations, solve for whatever is left over, and then plug whatever number you get back into the original. If you get both variables cancel out, and you get a false statement. So for example, a false statement is like 0 equals negative 1. Obviously, that's not a true statement. 0 does not equal negative 1. This is going to be a no solution case. Or if you end up solving it and you end up with a 0 equals 0, that is a true statement. You would get all real numbers. What does that look like? Especially those of you taking the SAT on Saturday. Sometimes this concept shows up. They ask you in what case is it a no solution, in what case is it all real numbers, or infinitely many solutions. If I have a line like this, how many solutions is that? No. They intersect at 1 point. So how many solutions is there? Are there? 1, right? So just one solution. What if I have a line that looks like this and a line that looks like that? Are they ever going to touch? No. So how many solutions are there? None, no solution, right? But if I have a line like this and another line just like it on top, how many solutions does that have? All real numbers, infinitely many solutions. So visually in this lesson, that's what that means when we say no solution or all real numbers, infinitely many solutions. This is visually what it would look like. Again, maybe that'll help you on the SAT, maybe not. There's always a system of equations, but that's what this would look like visually. And then of course the classic one solution case, you just get 1 point. All right, but let's start with these. So number one, I have a 3x plus 2y equals 4, 5x minus 2y equals 12. Again, the first thing with elimination, we want opposite coefficients. So look at your x's, look at the y's. Does anything have the same number but opposite? Which ones? The y's, right? We see that the y's have the same number but opposite. This one has a positive 2, this one has a negative 2. All right, so what you're going to do, if that's the case, this is the best case, because then you don't really have to do much. You just have to combine one equation with another, right? So let's add 3x plus 5x. What does that get you? 8x. And let's add 2y minus 2y. What does that get you? 0. So this is where we eliminate one of our variables, right? That's why it's called elimination. And then we do 4 plus 12. What does that get you? 16. And then we're left with this equation. 8x equals 16. So what is x? Good, right? Divide both sides by 8, and we should get x equals 2. All right, pretty easy. What should we do now to get y? Yeah, plug it into one of your two equations. It doesn't have to be both of them, but let's just say I wanted to plug it into the first equation. This is going to get us a 3 times 2 plus 2y equals 4, right? I'm just replacing the x that we see there with the 2. This is going to get us a 6 plus 2y equals 4. And let's solve for y. So subtract 6 on both sides. We get 2y equals what? Negative 2, and then divide both sides by 2. What do we get for y? Y equals negative 1, right? So I have a negative 1 for y and a 2 for x. How do we write our final answer? Nice, an ordered pair, 2 comma negative 1. So this is our final answer. All right, pretty easy. Okay, let's try the same thing with the next one. So we're looking for opposite coefficients with elimination. Is there anything that looks the same but has the opposite sign? Y's, right? We see that the y's, this one's a positive y, this one's a negative y. So let's just go ahead and combine these two equations. What do we get when we combine the x's? 4x, good. And then y minus y, what happens there? Cancels out, right? So then we get equals 4 minus 1. What does that get you? 3, right? So we get 4x equals 3. Let's divide both sides by 4. And then we get x equals 3 over 4. Right? Not the prettiest answer. You're not always going to get a whole number. Sometimes you get a fraction. It is what it is. We just roll with it. Right? What should we do with that number now? Plug it into one of our two equations. So let's plug it into the first one for x. If you plug it into the second one, you'll get the same answer. But if we do this, we get 2 times 3 over 4 plus y equals 4. And then what do we get when we do 2 times 3 over 4?
Would be 6 over 8.
Okay, how does that simplify? 3 over 4, right? So 6 over 8 simplifies to 3 over 4. So I get 3 over 4 plus y equals 4. And then what can I do to both sides? Good. Subtract 3 over 4. So then we get y equals 4 minus 3 over 4. All right, how do I combine that? Good, right? Over 1, get a common denominator. So I'm going to multiply this by 4. So I get 16 over 4. Top and bottom by 4 gets you 16 over 4. And then 16 minus 3, what does that get you? 13. Good, so we get 13 over 4. All right, how am I going to write the final answer? 3/4, comma, 13 over 4. Nice. So then this would be our final answer. All right, not too bad. Good. All right, we can try the exact same thing with the next one. Well, maybe not the exact same thing. What's different about this one? Do we have opposite coefficients?
No.
We do not.
Wait, what number are you doing?
I'm doing number 3. All right. So these do not have opposite coefficients. This is where you want to multiply one or both of your equations by a number to get them to have opposite coefficients. All right. What does it look like we can do to one of these equations? Okay. So depending on the problem, you're going to take a different approach. I would say let's try to eliminate the y's just because the 4 is already negative and the other one's already positive, right? So it's already opposite. We just need them to have the same number. All right, so let's try to get this negative 4y to look like this y, right? What can we do there? Is there any way to get one to look like the other?
You can multiply the whole problem by 4.
Good, right? So let's multiply this entire problem by 4. Again, it already has the opposite signs. This one's a minus, this one's a plus. We just want to get them to be the same number now. So let's go ahead and distribute 4 to everything. And this is going to get us 20x plus 4y equals negative 4. And then this becomes our new second equation. Right? Just to make it easier to see, you could just rewrite this top equation on the bottom now. So you can make this 2x minus 4y equals negative 7. Right? That way you can clearly see what cancels with what. All right, so let's go ahead and combine this. We're going to do 20x plus 2x. That's going to get us 22x. What happens with the y's? Okay, we add and then they cancel out, right? So we get 22x equals, what's negative 4 minus? Okay, good, negative 11, right? So then let's divide both sides by 22. What do we get for x? Negative, not 2, negative a half, right? Good. Nice, good, right? And now what we want to do, we just want to plug this into one of our two equations. So that way we can find y. All right, but that's the only difference with this one is that we had to multiply one of our equations by a number to get it to be the same number, just opposite, right? So let's take that, x equals negative a half. I'll just plug it into the first one. Doesn't really matter which one you do. Sometimes one is going to be easier than the other, but it doesn't really matter. You'll get the same answer either way. So we get 2 times negative a half minus 4y equals negative 7. What's 2 times negative a half?
It's gonna be 2/2.
Okay, so negative 2 over 2, which is negative 1. So we get negative 1 minus 4y equals negative 7. And then we just solve for y. Let's add 1 to both sides. We get negative 4y equals negative 6. And then we can...
Why would it be -2?
All right, and then so when you divide both of these by negative 4, we get what for y? Okay, well, as a fraction, it would be 3 over 2. Divide the top by negative 2, divide the bottom by negative 2. So we get x is negative a half, y is 3 halves, right? So as an ordered pair, this is going to get you negative a half, comma, 3 halves. And then that's our final answer. All right, are you okay with that one? Do not. All right, I'm going to skip number 4 just because it's pretty similar. Right, I kind of want to wrap up a little bit quicker than normal today, so. Okay. Okay, let's try this page now. So let's look at number 5. So let's have, we have opposite coefficients, same number, opposite sign. We do not, right? Do we have anything that could help us? Like, let's say, do we have an opposite sign already?
Yeah.
Which ones? The y's, right? We see that the y's have opposite signs. So I want the 3y and the negative 4y to be the same number but opposite. Is there anything we can do to get that to? Good, right? So we can multiply this top equation by 4 and this bottom one by 3. Right, that's going to get us the same number but opposite sign. So if we take that 4 and distribute it, then for the top equation, we should get 20x plus 12y equals 36. And then when we do the same thing with the bottom and we distribute the 3, we're going to get 6x minus 12y equals, I believe this gets you 42. Yeah, good. Okay. So let me get something like this. Do we see how multiplying by those two numbers helped us here? All right. All right. And then, yeah, so 4 and the 3 helped us get the exact same number. So now we're able to eliminate, right? When we combine this, we're going to get 20x plus 6x. So 26x. Now the y's are going to cancel out. And this is going to equal 78. Good. And now let's divide both sides by 26. Good, right? So we get x equals 3. All right, what can I do now to find y? Plug it back into one of our two equations. It doesn't matter which one. I'll just plug it into the second one. All right, so let's plug that in for x. So we get 2 times 3 minus 4y equals 14. So that's going to get us a 6 minus 4y equals 14. Subtract 6 on both sides, and then we get negative 4y equals 8. Divide both sides by negative 4, and we get y equals negative 2. All right, and then writing our answer as an ordered pair, we're going to get 3 comma negative 2. Right, it's always x comma y. All right, we okay with that one? Yeah, so hopefully it's not too bad. What about the next one, number 6? Does anything help us here? Or is anything opposite sign or anything? No, right? So really you can pick. It doesn't matter if you pick x or y to eliminate. Let's say we want to eliminate the x. All right, just because these numbers don't match, no opposite signs, it's a little bit of the trickier case, but still shouldn't be too bad. Let's say we want to eliminate the x. What's one way that we can get them to be the same number but opposite sign? Sure. Yeah, right. We can do the top one by -2. And then the bottom one, we can do 3, right? I still want them to get the same number, just the opposite sign. So just make one of them negative. If I distribute -2, that's going to get us -6x minus 4y equals -14. And then when we distribute 3, we're going to get 6x plus 15y equals 3. And then we can combine these, right? -6x plus 6x cancels out. -4y plus 15y is going to get us 11y. And then -14 plus 3 gets you -11. So pretty easy equation to solve. We divide both sides by 11. What do we get when we do? Good, right, -1. And then just like before, I can take that number, plug it into one of my equations. Let's just say I want to plug it into the second one. Then this is going to get us 2x plus 5 times -1 equals 1. So then we get 2x minus 5 equals 1. Good, we can add 5 to both sides, and then we get 2x equals 6. Nice, so divide both sides by 2, and we get x is 3. And then we can write our answer as an ordered pair. It's going to be 3, comma, -1. All right, not too bad. Nice. We just have 2 left. They're kind of the special cases. I think, if I remember correctly. Oh, wait, hang on. Sorry, this should say 2y for the second one. 4x minus 2y equals 2. All right, that's a typo. Sorry about that. All right, so let's try the same thing with this one. Again, nothing is opposite sign, nor are they the same numbers. So what can we do to try to get them to be the opposite coefficients? Sure, right? Let's multiply the top one by -2. And then when we do that, we're going to get a -4x plus 2y equals -2. When we combine that with the second equation, what do we get? What do we get on the left-hand side? What's 4x minus 4x? That crosses out. What's -2y plus 2y? That crosses out. So this whole side becomes 0. All right, so then all of our variables cancels out. This is a special case. All right, what happens with 2 minus 2? That's 0. So now you're going to check, is this a true or false statement? This is a true statement, so how would I write my answer? All real numbers. All real numbers. Another equivalent way to say it is infinitely many solutions. Infinitely many solutions. If you're taking the SAT, that's how they might word it, as infinitely many solutions. So this is an equivalent way to say that answer. Doesn't matter how you write it, they mean the same thing. All right, so that's one of our special cases. We okay with that one? All right, so we can try the same thing with number 8. It looks like these are both opposite signs. Let's just say we want to get rid of the x. If we want to get rid of the x, we're going to distribute a 2, right? So if we distribute a 2, we're going to get a 2x minus 4y equals 6. And then when we combine these, -2x plus 2x cancels out. 4y minus 4y also cancels out. We get 1. And then we get a 7 right here. Does 0 equal 7? That's a false statement, so this is no solution. All right, no solution here. All right, so those are the 2 special cases that you might run into. But otherwise, that's it for this lesson.